Hello guys, welcome to Examalist. So in our last lecture we discussed a lot of things about Newton's laws of motion. In this lecture we'll just change a bit of track and we'll discuss about circular motion. So what I'm drawing here a circle and this line is a diameter. Agreed? Now what I need you to think is that consider the distance from this point, that is point A to point C. So consider this point is point C. So distance between A and C over this circle. So if a person goes over this circle, then say the length is about 10 meter. Agreed? So the distance from A to C over the circle is about 10 meter. Now imagine that a person starts running with a velocity say 5 meter per second. So what is the velocity? I mean the tangential velocity. By tangential velocity, I mean that if this is the circle, then at each point the object is moving at a velocity 5 meter per second along the circle's curve. Okay, try to understand. If I am considering a circular motion, then I am always imagining that a person is moving with 5 meter per second along the circle. Okay, I mean tangent to the circle. That means that person is always moving on this circular path from here, from A to C. Agreed? So what is the velocity I said? The velocity that I have set is the person is moving at 5 meter per second. Agreed? Now can you tell me, so we know that the distance from A to C, okay, is 10 meter and the velocity is 5 meter. So what will be the time taken? So obviously time taken will be length by velocity and you'll get 2 seconds. Okay. So the ball or the object goes from A to C in 2 seconds. So it is better if I write a B here. So why I've written B here? Now I'll say. So what I'm trying to say is that a person goes from A to C through point B at 5 meter per second and he took a time of 2 seconds to cover from A to C through B. Agreed? The entire motion now can be seen in a different way. By different way I mean what is the angle from A to C? The angle from A to C is actually pi. So I can define a new velocity. Now that velocity will be different from the tangential velocity v, and that new velocity will measure how much angle it has covered. So what the new velocity will measure? The new velocity will measure the angle covered with respect to time. So what was the old velocity or the tangential velocity was covering? The tangential velocity was covering what was the distance covered with respect to time. And now my new velocity will say what is the angle covered with respect to time, and this I denote as omega. So can you tell me how much angle is covered from A to C? In A to C it has covered a pi angle, and how much time it took to go from A to C? It took 2 seconds. So what is the angular velocity? It is pi by 2 radian per second. It means in every 1 second, how much angle he is covering? In every 1 second the person is covering pi by 2 radian. Let us see if it is true or not. So when the person is let me clear the diagram a bit. Okay, so now as I said, the person has a linear velocity of 5 meter per second. Everything is okay with that. And now I define the same motion by using a different type of velocity that measures the angle covered per second. And let us see if pi by 2 radian per second angle covered in 1 second, that is the omega angular velocity, is saying the same thing. Let us see. So the ball starts from A in 1 second. Can you tell me how much angle it has covered? In 1 second it will cover pi by 2 radian. So in 1 second the object will be going from A and the object will be at B. In the next 1 second again it will cover pi by 2 angle. Okay, in the next 1 second again it will cover a pi by 2 angle. So it will go from B to C. So you can see that if the object is moving at pi by 2 radian per second angular velocity, then in 2 seconds it covers the pi radian. That that means it goes from A to C in 2 seconds. This carries the same information. Try to understand, this carries the same information that is carried by this velocity, just that the definitions are different. One measures in meter per second, that is how much length or how much distance is covered per second, and another object or another velocity measures in radian per second. Okay, some objects radian per second. Agreed? So what is the advantage? Why did we make this new definition of velocity? Was the old linear velocity not sufficient for us? Was it not sufficient for us? The answer is yes, it was sufficient for us, but for circular motion, to describe motions of an object along a circle, this helps us a lot. See, when you are studying tangential velocity, I mean when you are studying one dimensional motion, then to explain one dimensional motion, only linear velocity was enough, and that velocity was defined as the amount of length covered at a particular time. But when objects are moving in a circle, then the linear velocity is not enough. It is better we define some new quantities with respect to circle. So the first quantity we defined is the angular velocity omega, that is amount of angle covered per second. Agreed? Now let us try to understand what is the relation between omega and the linear velocity v from our example. Agreed? So let us do some calculation based on what we have learned from here. Okay. So if the length is 10 meter from A to C, okay, can you tell me how to calculate the length by using the circles equation? So length A to C by using the radius. So length A to C is pi r, because the full length is 2 pi r, that you already know, and so half the length is pi r. So what is AC? AC is 10, and this 10 is equals to pi r. So what is the radius of the circle? So the radius of the circle is 10 divided by pi. Agreed? Happy with that? Now comes a very interesting thing. The interesting thing is that if you multiply somehow omega and r, let us see what do we get. So what is our omega? Our omega was pi by 2. Agreed? And what is our r? Our r is 10 divided by pi. So we get what? We somehow get a number 5. And what was this number 5? Amazingly, this number 5 was the linear or the tangential velocity of the object. Okay, this number 5 meter per second is the linear velocity. So we see that the linear velocity of an object moving in circular motion is equals to the angular velocity multiplied with the radius. Okay, so this is the relation between linear velocity and the angular velocity. Now this was one type of derivation. Can we do some concrete derivation? Okay, let us do some concrete derivation. Okay, to do a concrete derivation that actually establishes the relation between v and omega. Okay, let us look at the basic definition of v and omega. So what is v? V is the amount of length covered along the circle with respect to time. This is v. Okay, or if I can write yeah, it's okay. Now what is omega? Omega is the amount of angle covered with respect to time. You know this very well. Agreed? Now there is an interesting thing about a circle. The interesting thing about a circle is that if you have a circle, then you see for a circle, a pi radian corresponds to what angle? Corresponds to 180 degree. A 2 pi radian corresponds to what angle? It corresponds to 360 degree. Agreed? So there is actually a relation between this radian and this length. Okay, so let us see. Theta is in radian. Theta can be written as L, that is the length over the circle, divided by R. This is the relation between theta, the length, and the radius of the circle. Agreed? Now, how do you get to this relation? Let us see. So, if 2 pi corresponds to 360 degree, it means that if I do 2 pi r, it will correspond to the entire length of the circle, entire circumference of the circle, that is L. That means if I look at this equation carefully, 2 pi is the complete radian that describes the full circle, that is a 360 degree, and this complete radian can be found if I do L by R. So from here it is clear that angle is equals to L by R. So this follows a concrete proof, but we are not done yet. We are not done yet. So if you do V by omega here, then what do you get? So if you do V by omega, the time will get cancelled and you will be left with L by theta. And you know very well what L by theta is from this relation. It is actually R. So what do you get? So V equals to omega R. So this completes a concrete derivation that relates the linear velocity with the angular velocity. Now you might have read in your books that V is actually written as omega cross R. So from where does this cross product come? You know, cross product means there is a sine theta term. So from where does the sine theta term comes? We'll discuss in the next lecture. But now let me tell you the direction of V, omega and R. So consider this is a flat plane. Okay, and upon this plane consider there is a circle. Agreed? Now the direction of omega is always perpendicular to the center of the circle. So this is the direction of omega. The direction of radius, you know, this is direction of radius, and you very well know what is the direction of the tangential velocity. The velocity is always tangential to the circle. Agreed? We'll discuss more in the next lecture.